Okay, so welcome back once again, you guys. So today we want to continue with our gas law. So the first thing we'll be checking today is combined gas law. The combined gas law. So this law actually combine the Boyle's law and the Charles law together. So that is what this law does. So everything under gas law, the things you need to do is that you ensure you know all the formulas in heavy law and the application. So you must know the formula for Boyle's law I give you. I hope you guys still remember. For Charles law, you must remember. And now we are considering Charles law. And when you want to use Charles law, you must ensure that your pressure, your volume, and your temperature, they all change. What did I say? You must make sure your pressure, your volume, and temperature, they all change. If not at the same time, at relatively the same time. It is very, very important you consider that. So what is the formula for the combined gas law? It is V1 over T1 is equal to P2 V2 over T2. That is the formula for the gas law. The P1, by now you should understand that this is talking about the initial pressure, right? That is your first pressure. Why this V1 is talking about your initial volume, right? Are we all together? Are we all together? Why this T1 talks about the initial temperature? You can see everything in this first formula here talks about initial, right? Please, can you all hear me? Titi, can you hear me? Okay. So everything in this first formula talks about initial, right? Initial pressure, initial volume, initial temperature, and the P2 talks about the final pressure, final pressure. The V2, yeah, talks about the final volume. While the T2 here talks about the final temperature. So you must understand this. So anytime they give you an inertial pressure, definitely to be your P1. Anytime they give you an inertial volume, definitely to be your P1. And anytime they give you an initial temperature, it will definitely be your T1. Same thing applies to the final pressure, the final volume, and the final temperature. Let's consider an example. I want you guys to do it using this formula. Let's use this as work example. Let's look at this question. They said a occupies gas occupies 250 centimeter cube at 100 kPa and 27 degrees. Now said find its volume at 200 kPa and 127 degrees C. Now I told you the right time. You must always convert your temperature to Kelvin, right? So you guys to remember. Anything we are doing, we are converting our temperature to Kelvin. So everybody, can you do that? Titi, Gift, easy. And Paul. You tell me the answer. So they want us to find the final volume, right? Isn't it? So you guys should use that formula. Okay, Susan, you are here. Welcome. One 66.6 centimeter cube. That's from Titi. Titi said 166.6 centimeter cube. Let me hear from one or two people more. Susan, I'm waiting for you. Waiting. It's a Paul. Susan gives. This is a jam question. You guys have to be very fast.
So I've sent my answer.
Yeah. Let me check. One 166.67. Why do you get kPa? What you are looking for is volume, right? I'm not looking for pressure or Paul. Paul, can you hear me? All right, centimeter cube. Gift 166.67 centimeter cube. Okay, so we have gift for Titilala. We got the same things. Confidence. Ferramia. Justice Alpha. Easy. Suzanne. Is there anyone here that does not understand how to do that? Justice solving. Okay. So let me give you 2 minutes. Justice Alpha. Solve it. So this is the answer. It's 166.67 centimeter cube. So TT for gifts. You all got it. So this is just combined gas law. It is combined gas law. So the formula is P1V1 over T1 equals P2V2 over T2. So anything they ask you to find, you just make what you are looking for the subject of the formula. Then you proceed with your question and the solution. So sometimes the most important thing is that always convert your temperature to Kelvin. Once you fail to convert your temperature to Kelvin, you may miss a lot of things. Is that taking everyone? Okay. So justice, easy, confidence. Fair on me. I didn't see your working, so. So let's move to another topic. Do you have anyone that want me to explain that concept again before we proceed? I want us to finish. Everybody is clear, right? Or Justice, do you want me to explain again? I don't understand your thumb up. Is that, do you want me to explain or you are clear? Which of the two?
Yes.
I should explain again.
Yes.
Okay. So we started with gas law and Boyle's law in the last class. So today we continue with combined gas law. When you combine Boyle's law and gas law together, you will have this formula. Confidence, okay. I'm explaining already. I believe you are not in the last class. So last class in our chemistry, we checked Charles law and Boyle's law. So I gave them the formula for Charles law and I gave them the formula for Boyle's law. And we solved one or two questions there. So today we proceeded to combined gas law. So combined gas law talks about the relationship between Boyle's law and Charles law. That you are trying to conjoin the formula for Boyle's law and gas law together. I would have proven it for you, assuming you are preparing for your WAEC or NECO, because sometimes they can ask for proving. But then JAM does not need proving. The only thing you need to know is to know the formula. So that is why I just write down the formula for you, which is P1 V1 over T1 equals P2 V2 over T2. So this is the formula for your combined gas law. And I was trying to explain what each parameters represent. Your P1, anything you see 1, it means initial, or your first constant value. For example, P1 means initial pressure, V1 means initial volume, T1 means initial temperature. So anything you see P2, you see 2, simply means final. So for example, P2 means final pressure, P2 means final volume, T2 means final temperature. So what you need to do here is to cram the formula if you are not used to it. P1 V1 over T1 equals P2 V2 over T2. Once you cram the formula, you won't have any issue. And how do you cram the formula? Anything 1 is in one place, anything 2 is in the other bridge. For example, P1 V1 T1, they are in one place, P2 V2 T2, then you are in one place. So just know that you are multiplying your P1 with V1 and you are dividing by T1 and you equivalent it to P2 V2, you divide it by T2. I believe that is taken. Anytime they give you a question under gas law, you must add or convert your temperature from centigrade to Kelvin. In case, because many times JAMB always leave the temperature to centigrade. And many people, if you don't convert it to Kelvin, you will still see the answer in your option. Like if you use centigrade value, you will still see the answer. I got it. I know. So they are trying to trick you. Always convert your temperature from centigrade to what? To Kelvin by adding 273. Is that taken? So once you add 273, you've already converted it to Kelvin. Then you can now proceed with your formula. Then you slot in all the parameters that you have been given. Now let's look at this work example. They said a gas occupies volume of 250 centimeter cube at 100 kPa and 27 degrees C. So everything they gave us here was for our initial. The V1 is 250, the P1 is 100, the T1 is 27 plus 273, which is 300. Is that taken? Then I said we should find its volume. So that means we are finding the final volume, which is our V2, right? At 200 kPa. That means our second pair, our P2 is 200 kPa, isn't it? Are you with me? And the final temperature is 127 degrees C. And you convert it to Kelvin. That would be 127 plus 273. And that should give us, that should be about 400 or so. I'm right. Then you slot in all these values into your formula. Justice, is that clear? Confidence, is that clear? Confidence, are you clear? Or you want me to solve it from beginning to the end? Confidence, I'm not seeing your reply. Confidence, or are you still there? Are you still there? Suzanne, do you get it? Suzanne, let me see your thumb up. Do you get it? Fermi, do you get it? Easy, is it clear? Okay. We got 125. No, it's not 125, it's 166. Do you convert the temperature to Kelvin? Convert the temperature to Kelvin. You will get 166. 166.67 into one decimal point. That's 166.7. So let's quickly move to the second topic because we have a lot of things to do today. Ideal gas equation. The ideal gas equation. So the formula for the ideal gas equation is PV equals nRT. Is that taken? I believe by now you should know what each parameter represents. This P represents pressure, right? This V represents volume, right? This N represents number of moles. This R, it represents your gas constant. It's a constant value. And this T represents your temperature. The temperature must be in Kelvin. Please don't forget this. It's very, very important. Please, do we all understand the formula? What you need to do in all this formula is that you need to cram them. Gifts, are you with me? Titi, you need to cram them. If you don't remember the formula, you cannot proceed with your question. So you have to cram, go and cram the formula for Charles law, the formula for Boyle's law, the formula for combined gas law, the formula for ideal gas law, for the molar volume law, the density, other laws that will be checking. You have to cram it. So don't mistake them together. You have to cram everything. So Just look at the formula, you can see PV equals nRT. So for the volume formula for R, they can give you any formula depending on what the question is talking about. Let's say, for example, now, when the prayer is, I need to restart my system again. Sorry. When the prayer is in Pascal, that is PA, and the volume is in meter cube, you will use 8.31. Please give me 2 minutes. I want to quickly restart my system. Nobody should go offline. Just give me 2. I'll be right back. Oh, sorry. I don't know. I've muted my mic. I've been talking since morning. So I was saying this is where we stop. I was trying to tell you that the value of your gas constant, which is your R, it can change depending on the pressure, the volume, and the need for the question. For example, when the pressure is in Pascal, which is PA, and the volume is in meter cube, and the volume is in meter cube, the value for R is 8.31 joule mole per Kelvin. I mean 8.31. Don't mind my joule mole per Kelvin. How that is taken. But when the pressure, because these are the place, when you use the wrong R, you will have issue, you will miss the answer. So that is just something that is tricky about this ideal gas equation. Once you don't use the right formula, you miss it. When the pressure is in ATM, that is atmospheric pressure, and the volume is in liter, and the volume in liters, you will use your R to be 0.0821 liter. Please, are you guys with me? Hope you understand what I'm trying to say. Very good. And when the pressure, which is the last one, when pressure is in mercury, millimeter mercury, your R is 62.4 liter mmHg mole. So we have these three formulas, these three numbers of R that you need to memorize. R can be 8.31 joule mole per Kelvin. R can be 0.0821 liter. R can be 6.62.4 mole liter per liter mercury, mercury, mole per Kelvin. But for your JAMB syllabus, they always use these two. Please, either this or this. So these are the two things you should pay attention to. So they always use pressure in atmospheric and volume in liters. So you will definitely use this, right? And if the pressure is in Pascal, you use this 8.31. Please, do you understand it? Majority of the time, they won't give you this. So you should pay attention to these first two values. Titi Lola, do you get it? Suzanne, do you get it? Suzanne, are you there? Justice, do you get it? Okay. Justice Gifts. Paul. Confidence, do you get it? So let's go for a work example. Someone should calculate. Gift, do you want to say something?
No, it's mistake.
A mistake. Okay. So calculate the volume of occupied. This is a typical JAMB question, but this question, if I'm you, I won't spend more than 1 second or 2 seconds at most in it. But calculate the volume occupied by 1 mole of gas at STP. That's the question. It's a JAMB question. Exit, what do you say? I should explain the scenario that brought about the different changes in the molar gas constant, Abi. Is that what you mean? I've explained that to you already. You come. Let me explain again before we proceed to this question. Please look at it. Do you understand this formula? Maybe I should write it again because of my writing. The formula for the ideal gas law is PV equals NRT. I believe everybody understands this formula, right? And I'll tell you what your P represents. Your P represents your pressure. It's sharp, sharp. Your P represents your pressure. Your V represents your volume. Your N represents your number of mole. Your R represents your molar gas constant. Your T represents your temperature. Is that taken? But I said there's something that is very trickish about ideal gas law. Jam like asking question here because they know that some of you don't have chill. You will misplace your R, like your molar gas constant value. Your molar gas constant can be in three forms, depending on the mood of the question, depending on what the question is aiming at. And I said, if the pressure in the question is in ATM, atmospheric pressure, and the volume is in liter. Okay, Titi, I'm coming. If the pressure is in atmospheric pressure and the volume is in liter, what value of molar gas constant should you use? Use R equals 0.0821 liter. Look at the question. Is the question telling you that the pressure is in ATM, the volume in liter? You use 0.0821. But if the question says that the pressure is in Pascal, you know Pascal is different from ATM. Are you there, Hazy? You know Pascal is different from ATM. So if the question says your pressure is in Pascal and your volume is in meter cube, the value of the R you'll be using is 8.31 joule per mole per Kelvin. Is that thinking? You know, Pascal volume, Pascal and meter cube is different from ATM and liters. Please, are you with me, everybody? So the formula, the value of R that we are going to use depend on the unit of your pressure and your volume. If your pressure is in Pascal and your volume is in meter cube, once your pressure is in Pascal, definitely your volume will be in meter cube. So you have to use 8.31. But if your pressure is in ATM, my brothers and my sisters, you use what? 0.0821. Is that thinking? Is that thinking, please? Hope you understand it now. Eloise, hope you understand it. If you don't understand it, okay. Eze, hope you understand it now. Eze, please talk. You don't ask question. No. Suzanne, you don't understand it. Hey. Suzanne is very simple now. What don't you understand there? This is the formula, right? PV equals nRT. Do you understand the formula, Suzanne? PV equals nRT. Okay, so what's the issue? Is it your R value? This R, Abi? Is the issue, Abi? Okay, your R has two numbers. The number you are going to use depend on the unit of your pressure. Your R has two numbers. Sometimes they provide the value of the R, sometimes they don't provide. That's what I'm saying. Now, in case they want you to miss it, they won't provide the value, but sometimes they provide the value. Your R has two values. Is either your R is in 8.31 joule per mole per Kelvin, or your R is in 0.0821 liter. Do you see that they are different? Suzanne, are they not different? Now, how do you know when to use this? How do you know when to use this? You use this when your pressure is in Pascal. You use this when your pressure is in ATM. That's just the difference. So look at the unit of your pressure. Is it in Pascal? You use this. Is it in ATM? You use this. It's very simple now. Is that okay? And sometimes you can be lucky. They will give you the number of your half. But in case they don't give you, you should be able to get it yourself. That's what I'm trying to say. So it's very simple. Then it's slot in your formula. PV equals NRT. They ask for, look at the question. They ask for V. If you make V to the formula, we have V equals NRT over P, isn't it? Then you slot in all your parameters there. What is your N? Your N, you said at 1 mole, right? That will be 1 multiplied by your gas constant, since your pressure is in ATM. That means the gas, they don't even give us, they just calculate the volume. So let's use this one. We can use any of the two, actually. But let's use this one. That would be 0.0821 multiplied by your temperature at STP is 273 divided by what else? Your pressure. So pressure, if you are using this, your pressure should simply be 1. Yeah. So you can multiply it. That will give you your answer. And you can use 8.312 to anyone. Please, is that taken? We'll see some other questions as we proceed. It's very simple. Please, let's quickly write it. I'm waiting for you guys. Yeah. So I believe everybody gets it. So let's quickly move to, let me, is somebody trying to talk?
Yes, I'll be trying.
What do you say?
Yes, I have a question.
Okay, Alpha, Titi, what's the question?
So activity SCP temperature is 273 Kelvin, and then pressure is 760 millimeter mercury.
What do you say? Prayer is what?
760 millimeter mercury.
Yes.
But it was when you used. That's why I'm confused.
You are confused on what?
Because you used 1.
Because I'm using 0.0821. I'm using prayer at ATM. I'm not using at millimeter. I told you now, when you are using prayer at Pascal, have you forgotten, Titi? You can use either of this number. Either you use 8.31 or you use 0.0821. If you are using 8.31, you use that prayer value, you still get the same thing. If you are using 0.0821, you will use prayer to be 1 because that is the standard prayer.
Okay, sir.
Do you get it?
Yes, sir.
It depends on the pressure you are using, on the gas constant you are using. If you are using this gas constant, you use that number. If you are using this gas constant, you use this number. It's very simple.
Okay,
So
sir. Thank you, sir.
you're welcome. So let's quickly move to molar volume. That's second to the last topic for today. I want us to check as many as possible, many questions as possible. Let's move to molar volume and atomicity. Molar volume and atomicity. So molar volume and atomicity. Molar volume is actually the volume occupied by 1 mole of a gas. It is a volume occupied by 1 mole of a gas. So the general volume formula for molar volume is volume of gas divided by the number of mole. That is molar volume. That's Vm equals V over N. That's volume of gas. Give what happened.
Be coming down.
I should be coming down.
Mm,
Am I too fast?
yes.
We have a lot of. I'm not fast though.
Yeah, it's not fast.
We have a lot of things to cover. I'm serious, and I want you guys. I want us. I want to cover many things as possible. Your exam is April, so that's what I'm trying to.
Okay. Can you give like the definition of molar volume again?
Molar volume is a volume occupied by 1 mole of a gas. It's very simple. It is the volume that is occupied by 1 mole of a gas. So look at the question they asked the other time. I want to pay your attention to something here, because you'll have been seeing it that 1 mole of a gas, of any gas at standard temperature and pressure, will always be 22.4. Are you with me? So anytime you see the, that's why I said when I gave you this question, even without me calculating, I know the answer. This calculate the volume occupied by 1 mole of a gas at, once you see, at standard temperature and pressure. 1 mole of a gas is what? 22.4 liter or 22.4 dm cube. It's still the same thing. Is that taken? Now let's assume the questioner says calculate the volume occupied by 2 mole of a gas. Who will tell me the answer? At standard temperature and pressure. Hello? Are you guys even flowing with me?
I think it is.
Exactly. That's what
44.8.
Yeah, 44.4, 44.8. 44.4. This is so even without you calculating, since you know that 1 mole of a gas at STP is 22.4, definitely the volume occupied by 2 mole of a gas at standard temperature and pressure is 44.8. If they ask you for theory, you multiply 22.4 by theory. That should give you, I'm not with my calculator, but maybe around 72 point something, I can't remember. So that's just it. That's just the logic about it. So let's continue with molar volume and atomicity. I just remember that in case they give you a question like that in your exam hall, don't waste your time doing calculation. Just go straight to it and all. So monoatomic gases, they are gases that they don't have, they are not diatomic, they are not triatomic, they are not tetratomic, like He, like Ne, like Na, and all. But we have diatomic gases. I'm talking about atomicity now. We have the monoatomic, we have the diatomic, the monoatomic, like He, like Ne, the diatomic. like H2, like O2, like N2, the triatomic. Like O3, or let me say like CO2, like H2O, and all. So all these things will be applying it under the molar volume and atomicity, because atomicity will affect the relative molecular mass, but it does not affect the gas law. Actually, I will give you one example on this. Let's check the last topic. I will give you one example, then we start with jam past question. And that is vapor density and relative molecular mass. That's the last topic for today. Please quickly write that on the board. Sir, go right again. Suzanne. And relative, I'll go right. Relative molecular mass. Okay, so I was talking about the molar volume and atomicity. I believe you guys get the definition for molar volume, isn't it? Suzanne, do you get the definition for molar volume? Yeah, you didn't get it. Okay. It's very simple now. I said molar volume is the volume occupied by 1 mole of a gas. Molar volume is the volume occupied by 1 mole of a gas. Is that taken? Molar volume is the volume occupied by 1 mole of a gas. Jam will not be asking you. When they can ask for definition, I've seen like 2 questions like that when I was taking your past questions. They ask for definition, but it is very rare. They ask for application of your definition and your formula. Is that taken? And I gave you the general formula for molar volume, which is Vm equals V over N. Suzanne, unmute your mic. I think some furniture people are working over there. All right, thank you. So Vm equals V over N. So your V is the volume of gas and your N is the number of mole. The Vm is the molar volume. So anytime they ask you to calculate your molar volume, they will give you the volume of the gas and they give you the number of mole. For example, they can say a gas volume of maybe let's say 12 centimeter cube has a number of mole of something, probably 2. We ask to calculate the molar volume for that gas. So it's just 16 that be 12 over 2. And you get your molar volume. Is that taken? So that's what I was trying to explain over there. So let's quickly move to vapor density and relative molecular mass. The relationship, this aspect in gas law is about formula. Once we can memorize the formula, we don't have any issue. For example, this relative molecular mass it has a relationship with it's RMM equals to multiplied by vapor density. This is the relationship between the two. Can you see? Your relative molecular mass is your RMM, and your VD is your vapor surface density. If you have to calculate your vapor density, to be VD is equal to RMM divided by 2, isn't it? It's not simple. Now, somebody should do this. It's actually part of your. If you guys can actually read everything I've been teaching you, you will see that you can have 80 in your chemistry and your biology. You can have a score of 8. Yeah. They are very, very simple. 44. That's Paul, right? What about that? What about that, please? Hello. Gift Suzanne. I hope you guys got the same thing, right? No unit, yes. Okay, Lillian, how are you? 44. Okay, that's good. So I believe everyone understands it now. If they ask you to predict the likely gas, what can be the likely gas? Looking at that relative molecular mass, that's 44. Anybody? Anybody, please?
Sir, CO2.
CO2, very good. That's CO2. So, hope you guys understand everything, please. But let me assume, CO2 is 12 plus 16 times 2, right? And that will give us 44. Okay, that's 24 grams per mole. So, I believe we are good to go. So, let's go to question and answer session. That's the last topic. Next class, we move to pH, pOH, and acid-base calculation. But give me some minutes. I want to fetch some questions for you. So I'm trying to get some questions for you. Okay. So how are we going to do it? You guys are nine, I think. So that means you guys will do. I'm trying to look for more questions. So who's going first? Let me look at. So confidence, you go first. Eze, you go second. Justice, you go third. Pelmi fourth. Lillian fifth. Gift six. Paul seven. Suzanne eight. Titi nine. Please, do you get it? From confidence to Eze, justice. Okay, to Pelmi, to Lillian, to Gift, to Paul, Suzanne, and Titi. So let's wait like that. See you at the last, Bella. So this question is also under what we just coming. Okay, confidence. Let's go with question one. This Jam 2010 question. So confidence, we are waiting for you. Confidence. Are you there? What's the answer? D. The question says which system is the beer of gas? No, that is not right now. We are talking about gas. Are you guys know? Gas don't have fixed position. No. Sorry, I lost my network. Can you guys hear me now? Okay. So I'm asking, who can tell us the answer for the question there? The answer is B. Yeah, gas particles move randomly and they collide elastically. Confidence, please. Do you get that? Confidence, do you get that? I gave you all these notes. I gave you the properties of gas, solid, and liquid. So let's move to the second one. So who's the second person? Is it right? Please, big guys, be fast, please. What's going on? You guys are very slow today. As for that temperature, the volume of the face marker is said B. Charles law. Yeah, that's correct. Boy's law actually explains the relationship between pressure and volume at constant temperature. Yeah, that's good. So justice, over to you. Your own question is a calculation question. Justice Alpha.
I'm calculating it.
Okay.
Answer B.
Answer B. That's 100 centimeter cube. Someone should help me confirm. Okay, Eze said B. Okay. Another person. Oh, okay, that's good. So who's the next person? Very good. So do this. No, you cannot answer for her. She has to answer first. Tell me, what's the answer? B. Which law states that the volume of a gas is directly proportional to its absolute temperature at constant pressure? Yeah, that's what Charles law stated. It shows us the relationship between volume and its absolute temperature. That's very correct. So anytime you see uh volume and temperature, it is Charles law. So who's the next person? Lillian, how are you? I've not heard from you since all this while. Uh, sorry for that. Someone just entered my apartment. Okay, so let's continue. Okay, Lillian, how are you? Hey, Dan, please let me on there. 4 minutes to shut down. Ah, tell mom, Papa.
Guys, please, what's going on now?
Oh, sorry, guys. So where are we? Lillian, have you gotten the question? Sorry, guys. My data just went off. So sorry for that. So Lillian, have you gotten the answer? What was your answer? So do you know it? Are you having issue with it? Hello, talk to me. Do you want us to help you? Or you are still solving it? Or is this Boyle's law or Charles law? We are talking about volume, they are talking about temperature. Okay, now look at the question. You must know the law they are referring to. They said a gas has a volume of, they give us volume, they give us temperature. So anytime you see volume and temperature relationship, that should be Charles law, right? Thank you, Eze. So that is Charles law. So that means you are using Charles law formula, which is V1 over T1 is equal to V2 over T2. Lillian, do you get it? The reason why we are using Charles law is because we are talking about relationship between volume and temperature. Please, is that taken? All right. And if you remember the formula I gave you under Charles law, I said V1 over T1 is equal to V2 over T2. So we are using this formula to solve the question. Look at the temperature here. They give us in centigrade. The second thing I told you is that you should convert your centigrade to Kelvin. Just remember that. So if you are converting the temperature to centigrade, so that would be V1, your T1, which is equal to 27 degrees C. Converting to 10 centigrade, that would be plus 273, isn't it? 27 plus 73 give us 300 Kelvin. Do you get that? Lillian, do you get that? All right. So the temperature too is in 127 degrees C. You convert it to Kelvin also. Any temperature you are being given under gas law, you have to convert it to Kelvin. This one will give us 400 K. So we have our temperature 1 to be 300, our temperature 2 to be 400. The volume 1 is 300. They now ask us to calculate this volume 2. So you insert all these things into the formula. So
Daddy,
V1, what do you say?
the volume 1 is 27, not 24.
Volume 1 is 300 now.
I mean the temperature one.
Temperature is 27. Temperature is 127, isn't it?
Okay.
That's what I did, right? I did 27 and 127. So the V1 is 300. So that would be 300 divided by the T1 is also 300, right? That divided by 300 equals the V2. We are looking for the V2, right? Over the T2 is 400, right? Then we cross multiply. That would be 300 V2 is equal to 300 times 400. That would be 12,000. Then you find your V2. Your V2 is equal to 12,000, 120,000 over 300. So that will give us 400 centimeter cube. It simply means our V2 is 400 centimeter cube. Is that taking million? So that means the answer is C. So the first thing, anytime they give you a question, look at it. Is it a gas law? Is it a Charles law? Is it a Boyce law? Is it a combined law? Is it an ideal gas law? Once you check where it belongs to, then you use the formula. If it's a Charles law, you should know where to use. If it's a Boyce law, you know what to use. If it's a ideal gas law, you use PV equals NLT. If it is a combined gas law, use P1 by T1 equals P2 over V2. So it's very, very simple. So let's move to the next question. Who's the next person, please? You don't know what to signify. Who's the next person?
It's me.
Gifts. Let me check. Okay, it's gifts. If you don't get it, you will see me in your room just right now. I will even call daddy. I will call your dad. Don't worry. All right. Which of the following quantities must be kept constant for Boyce law to be valid?
Temperature.
What is it?
Temperature.
Yeah, very good. Yeah. Eze, you don't know I'm a Spider-Man. Okay? Don't try me, sha. Yeah, that's right. That's temperature. So temperature is constant for Boyce law to be valid. If temperature is not constant, that means you cannot fulfill Boyce law. Please, do we all get that? All right. So I'm coming. So I'm coming, please. So who is the next person?
That is me.
Okay. This question is on formula, but it's not well arranged very well. I'm trying to help you arrange it. So I'm trying to retype the question. They did not arrange it very well for you. So this is the question. Very good. That is straightforward. The next person, please. Who's the next person? The next person should signify. Hello, who is the next person?
I think Suzanne is the next person.
So why is she not talking? Suzanne, are you not there? Why not talking since morning? What is the answer? Suzanne, please, we are waiting for you. We did this thing during the class, so it shouldn't take you 2 seconds. You guys are not making me proud. Oh. That's the option there now. Can't you see the screen? Who is the next person?
I'm the one, sir.
Okay, Titi, this is very simple. Very good. See. All these questions are very simple. Who is the next person, please? Do you have another person there that has not done anything today? We don't have, Abby. Okay, someone should answer this. Lillian, answer this. Lillian, are you there? Lillian, are you there?
She has answered, sir.
What's the answer? Can you type again?
She
I can't
said
see it.
to
She said what? C. Yeah, that's right. You're correct. So I believe everyone understands everything we've checked under gas law. You can answer any question under gas law, right? So this is what I want you to do for me. Please go and by now you guys should have a past question now. You should have past questions. Go and check your past questions and check every question on how you've learned so far. The topic we just finished treating is kinetic theory of matter and gas law. So go and check everything under it. If there's anything at all that you don't understand in this topic, then send the question to the group. So your friends will be able to do it. And if they don't get it, I will go ahead to explain for everybody. Please, is that taken? Is that taken, please? By now, I believe from all the topic we've considered so far, we've considered about four major chapters now. Is there any topic you are still having issue with? I mean, for those that started with the class with us.
sir, there's a question that I wanted to ask in
Under this
class.
topic, Abby.
No, under this topic, on the last topic, when Susan and I were going over it, we
Okay.
saw a question that we're not quite sure about.
Can you send it to the group then?
Okay, sir. Yes, sir.
Send it to the group. So maybe we use this for the night class. Is that okay? All right. So we'll be ending the class here. We'll start another chapter on that should be on Friday, Abby. So before we meet on Friday, this is what I want you to do for me. Like I said, go and dust your past questions and start checking them. Check all the topic you've learned so far, you've been taught so far, and tell me the ones you find difficult to understand. So I can quickly do a little recap in one of the classes we'll be having subsequently. Then you'll be able to travel with us. I want us to be very fast. At least every class we should finish the chapter. So with that, we still have about 10 days to go. I mean 10 classes for chemistry. So we can cover every chapter and topics. Is that okay? So you guys will be dropping the curtain here. Benita, you're just joining us. You are kind of late. So confidence is a Justice, Feromi, Lillian, Gift, Bob, Suzanne, and Titilola. I wish you guys a good day. Hope you understand everything you learned so far today. All right, thank you. So give me a love emoji before you go. Let's end it on that. Thank you. Thank you. You guys take care of yourself and have a good day. Yeah. Bye bye. Yeah. Thank you. Gifts. Bye bye. Yeah. Thank you, Suzanne. Thank you, Confidence. Yeah, thank you.